Hello everyone, and welcome once again to the mathematics class. Today, we want to continue with our current topic, which is the surd. If you can recall very well, we stopped under the addition and subtraction of surds. So today, the class is going to begin from the aspect of the multiplication of two or more surds. So, and that has to start by the way of example. So example 1 for today. Example 1 for today. Simplify the following. Number 1 there, I have root 7 multiplied by 5 root 2. Number 2, root 10 multiplied by 3 root 2 multiplied by 5 root 8. Number 3, root 6 multiplied by 2 root 5 multiplied by root 30. And finally there, I have 11 root 3 squared. So solutions. Number 1, what I have here is root 7 multiplied by 5 root 2. Now multiplication of surd involve this. What it involves is that elements we have in the root, that is surd, can only multiply surd, while coefficient of surd can as well multiply the coefficient of surd. But before this multiplication is carried out, we must first of all ensure that the surd given to us is in its basic form or in a simplest form. So to deal with this question means I will have to multiply the coefficient of this surd, of the first surd, by the coefficient of the second surd, as well as the first surd multiplied by the second surd. So far they are both in their simplest form. Now when we look at the first question, the first surd here, so we're going to observe that it doesn't have any coefficient. So once it doesn't have a coefficient, we can assume 1 to be its coefficient. So to multiply now means coefficient will multiply coefficient and surd will multiply surd. So when I say 1 times 5, we can see that gives the result of 5. Then root 7 multiplied by 7, that gives what? 14. And we can see that 14 which I have here cannot be simplified further. We can as well say this 14 is in its basic form, because it's not possible for me to express 14 in such a way that one particular number will repeat itself 2 times. So since there is possibility, since that is not possible, so the result this thing will give is what? 5 root 14. So result of multiplying root 7 by 5 root 2 give the result of what? 5 root 14. So that is number 1. So in number 2, what I have is root 10 multiplied by 3 root 2 multiplied by 5 root 8. To do this one, what we're also going to do is not different from what we did in the first place. So we want to ensure that the coefficients of our surd multiply the coefficient while surd itself multiply surd. While surd itself multiply surd. But one very first thing that has to take place is that we want to ensure each surd which we have here occur in their basic form. When we look at the first surd here, we can see that it is in its basic form, because there is no way we are going to split or re-express 10 in such a way that we have a number repeating itself 2 times. So likewise the root 2 which I have here, so we can see this one is also in its basic form. But when we observe this 8, root 8 which I have here, we can see it is not in its basic form. So the first job we should have to do here is to ensure we reduce it to its basic form. So the solution will go like this. It will be root 10 multiplied by 3 root 2 multiplied by 5 multiplied by root. Since we said this 8 is not in its basic form, It means 8 will have to be broken down to its smallest components. And if we can recall from part of what we did in the last class, breaking 8 down to its lowest component will be like this. 2 in 8 gives 4, 2 in 4 gives 2, and 2 in 2 gives what? 1. So that's going to be 2 times 2 times 2. And the result that gives is going to be root 10 multiplied by 3 root 2 multiplied by 5 times. So remember how we are going to split this bigger root here. So that's going to be 2 times 2 multiplied by root 2. So that becomes root 10 multiplied by 3 root 2 multiplied by 5 times 2, because this one becomes 2 multiplied by root 2. So under the adjustment, the question will now be reduced to root 10 multiplied by 3 root 2 multiplied by 10 root 2. Now that we can see that every element given to us here are in their basic form, multiplication can now take place. And what we do in the multiplication is that we allow the coefficient to multiply coefficient as well as surd multiplying the surd. So we can see the coefficient of this surd here is 10, coefficient of this surd here is 3. Why this one has no coefficient? And it's when whereby no coefficient is given, we are going to assume the coefficient to be 1. So multiplying this time around now means 1 times 3 times 10. We know 1 times 3 gives 3, and 3 times 10 gives what? 30. That's going to be 30 root. Now each element in the surd we also multiply each other. 10 times 2 here gives 20. 20 times 2 here gives what? 40. Now to round up with our answer also means that we have to check this 40 whether it is in its basic form, but to know whether it is in basic form or not, so what we can do is let us position our 40 here and reduce it to 1. So far, once we observe any number repeating itself more than once shows this thing is not in its basic form, and as a result we are going to adjust it back to its basic form. So the division can start with 2. 2 in 40 here gives what? 20. 2 in 4 here gives 20. 2 in 20 here gives 10. 2 in 10 here gives 5, and 5 in 5 gives 1. So which means this is going to be 30 multiplied by root. This 40 is now going to be written, that this is going to be expressed in another form by writing it as 2 times 2 times 2 times 5, which is the same thing as 30 multiplied by 2 times 2 multiplied by 2 times 5. And we can see, so this becomes 30 times. So we can see this one becomes 2 multiplied by root 10. So the result that gives is now 30 times 2 is 60 root 10. And this also completes the solution to the second question. So in number 3, what I have there is root 6 multiplied by 2 root 5 multiplied by root 30. So if you've been following since I started solving this question today, we are going to observe that the very first thing we want to do is to ensure each surd given to us here occurred in their basic form. So we can see this 6 is in its basic form, root 5 I have here is in its basic form, even root 30 I have here is in its basic form, because there is no way I can re-express 30 for me to have any given number repeating itself. So it shows everything I have here are in their basic form. Now that everything are in their basic form, I can now go ahead straight into the multiplication. But one other thing I have to consider for in my multiplication is I must ensure each surd has a coefficient. And it's a situation whereby there is a given surd which is without a coefficient, we will automatically give to it a coefficient of what? 1. So here I will assume the coefficient to be 1. I will also assume my coefficient here to be 1, so that the multiplication can flow smoothly. So what we rather do now is that the coefficient will multiply. Now 1 times 2 gives 2, and 2 times 1 here as well gives what? 2. So that's going to be 2 root. Now 6 times 5 here gives 30, and 30 times 30 gives what? 900. And when we observe this thing very well, we are going to see that this 900 is not in its basic form, so it has to be reduced to its basic form in order for us to get our final result. So that's going to be 2 times. Now I will have to split my 900, so doing it will involve this process. So I will reduce it until it becomes 1. 2 in 9, 9, 4. 2 in 10 here, 5. 2 in 0 here is 0. 2 in 4 here is 2. 2 in 5 here is 2. 2 in 10 here gives 5. 3 can work now. 3 in 22 here is 7. 3 in 15 here is 5. 3 in 7 here 2. 3 in 15 here 5. 5 in 25, that is 5. And 5 in 5 here gives what? 1. So that will be written as 2 times 2 times 3 times 3 times 5 times 5. And that becomes 2 times. So now needs for us to what? To regroup. So that's going to be 2 times 2 multiplied by 3 times 3 multiplied by 5 times 5. So that is the same thing as 2 times. We know this one becomes 2, this one becomes 3, and this one as well becomes what? 5. And when we multiply this together, we have 2 times 2, 4, 4 times 3, 12, and 12 times 5 gives what? 60. So that means the result of multiplying root 6 by 2 root 5 by root 30 gives the value of what? Root 6. It gives the value of 60. That is number 3. Now in number 4, what I have there is 11 root 3 squared. Number 4, I have 11 root 3, everything here squared. So doing this is the same thing as saying that 11 root 3 multiplied by 11 root 3. And for us to multiply is to consider the surd. Surd is the most important thing here. Are those elements, those surd, that is those elements in the root in their basic form. So we can see this is in its basic form, this one is as well is in its basic form. As a result, we can go ahead to multiplying. And what we want to do in multiplying is that the coefficient will multiply the coefficients as well as the surd multiplying surd. So 11 times 11 here gives 121 multiplied by 3 times 3 here gives what? 9. So which is the same thing as 121 multiplied by, this one can easily be splitted, or we can easily say that square root of 9 here gives what? 3. And what is the result of 121 by 3? 3 times 1, 3, 3 times 2, 6, 3 times 1, 3. So the final result we get there is 363. So that is that on the multiplication of 2 or more surd. Now we want to progress to the division of surd. Division of surd. So that one is also going to be illustrated by the way of example. Now let me have example 1. Example 1. We have to rationalize. I have to rationalize 1 over root 3. Now before I go ahead into talking about the division of surd, so this is very important. This point I want to talk about is very key, which student has to take note of. And the point is, the process of dividing surd is what we call rationalization. The only way by which we can divide surd is what we call rationalization. And when exactly do we rationalize? So rationalization of surd occurs only in one place, and that is the situation whereby our denominator has an element, has a surd, it contains a surd. Now before I solve this, let's consider this thing. What if I have 1 root 2 over 3? So this one is not talking about division of, we cannot rationalize in this situation. So the only case whereby rationalization, that is, we can rationalize our surd, we can divide our surd by rationalizing, is when the denominator contains the root. But once the denominator do not contain the root, there is no possible for us to rationalize it. That shows this thing is in its basic form. But whenever the division of sort given to us has the denominator as a number in sort form, it will always call for rationalization. So I hope you can now know the difference, why we can rationalize this, why, and that this one is not possible for us to rationalize. So to solve this one now means I'm going to multiply by root 3 divided by root 3, and this is what is called rationalization. And I want to state some things once again. To rationalize means we are allowed to rationalize when denominator contains a root. And how do we rationalize? We rationalize by picking this number. This number, we express it as both numerator as well as denominator. That is what we call rationalization of any number. So I will have to state that once again. To rationalize simply means I will multiply the initial result given to me here by this denominator. In this case, denominator of root 3 which I have here will act as both numerator as well as the denominator. So whenever we have any expression of this form, that is what we call rationalization. So to fully complete this thing now means we are going to multiply. So we can see that what I have here is just ordinary number, just like so. I will multiply by root 3. The result that gives is root 3 over root 3 multiplied by root 3. We can assume it to become what? To become 3. It's just like we have a root containing 3 times 3 like this, and we know of our result that gives is what? 3. So this is the answer. But this answer can be expressed in another form by writing it as 1 over 3 root 3. So that is the final result to that example 1. So I shall continue with the example now. Example 2. Rationalize the following. Number 1, 7 over root 7. Number 2, 3 root 2 over root 10. So solutions. So in number 1, what I have is 7 over root 7. So to rationalize it, we have to consider it first. Is this still rationalizable? So we can see it is rationalizable. Why? Because the denominator contains a surd. So to rationalize now is to say what I have here multiplied by this number will now be repeated 2 times. I will write it as root 7 over root 7. So that now becomes 7 multiplied by root 7 automatically gives 7 root 7 over, when root 7 multiplied by root 7, it automatically becomes 7. So when this cancel this, the final result I have now is what? Root 7. Now in number 2, what I have there is 3 root 2 over root 10. Now we have to rationalize this one as well. So whenever in any situation whereby we have to solve question like this, the very first thing that we must consider is whether the stuff we are given, whether the expression given to us here is rationalizable. But when we observe this thing very well, we can see that it is what? It is rationalizable because the denominator contains a sum. That is, the denominator contains the number in root form. So to rationalize simply means to say what I have here multiplied by this number will occur 2 times. In the first time, it's going to occur as numerator. Second time, it's going to occur as the denominator. Now, to multiply, now this now calls for multiplication. So we can see this one. This one here has a coefficient, but this one is without coefficient. We can assume its coefficient to be 1. So 3 times 1 here gives 3. Root 2 times 10 here gives 20. Everything over. We can assume it to be 10 because same number in the root gives the value of 10. Now to present our answer, we have to check this number, root 20. We can see this root 20 is not in its basic form, so we have to adjust back to the basic form before we can conclude our answer. And that is going to be 3 multiplied by, so when we break down 20, so it's going to be 2 in 20, 10, 2 in 10, 5, and 5 in 5 gives what? 1. So that is going to be 2 times 2 times what? Times 5. Everything here over 10. And that's going to be 3 multiplied by, then I will have to regroup here, 2 times 2 multiplied by root 5. Everything here over 10. And the result that gives is 3 multiplied by, so we can see this one combined together to produce 2 multiplied by root 5. Everything here over 10. And division is possible. Now we cut where possible. 2 into here gives 1. 2 in 10 here gives what? 5. And the final result now is going to be 3 root 5 over 5, which we can as well express as 3 over 5 root 5. And with this, we've also concluded our discussion on the division of any two given surd. Now we want to take some additional worked examples involving multiplication of surd. Additional worked examples. So number 1, I am asked to simplify root 6 plus 2 multiplied by root 3 plus 2. So solution to this, so I will have to reproduce my question, root 6 plus 2 against root 3 plus 2. The very first thing that I want us to consider in solving this question is whether what we have here is in its basic form or not. So we can see, especially those elements in the root, so we can see those surd given to us here are in the basic form. Then what follows now is we ensure we open the bracket. And remember, to open a bracket simply means to multiply. And the approach I will use is this. So it means this root 6 will multiply everything in this bracket, and plus 2 here will multiply everything in the second bracket. So that becomes root 6 into root 3 plus 2. And the second number plus 2 will also multiply what I have there, root 3 plus 2. So this now gives root 6 multiplied by root 3 is 18 plus root 6 times 2. So we can see this 2 is a normal number, is a whole number. It's only going to multiply the coefficient of this root. And remember, the coefficient this root 6 has is 1. So 2 multiply 1. Since 2 is not a surd number, it can multiply this root 6. So the result that gives is 2 root 6. Then we'll go over to the other one, plus 2 multiplied by root 3. Just like the explanation I gave here, the result that gives is 2 root 3 plus 2 times 2 here, that gives what? 4. And the rest is we collect the like term where possible. We know this will now involve addition of surd. And remember, under the addition of surd, the very first thing we want to do is to consider this thing and reduce them to their basic form where possible. So we can see this one is in its basic form, this one is in its basic form, but this one is not yet in its basic form, so it has to be converted back to its basic form. So I have my 18, 2 in 18 give 9, 3 in 9 gives 3, while 3 in 3 here gives 1. So it means 18 can be rewritten as 3 times 3 times 2 plus 2 root 6 plus 2 root 3 plus what? Plus 4. And that gives 3 times 3 multiplied by root 2 plus 2 root 6 plus 2 root 3 plus what? Plus 4. And these two combine to give 3 root 2 plus 2 root 6 plus 2 root 3 plus 4. And for us to add, we need to consider the concept of similar surd. Addition or subtraction of surd is only possible in situation of what? In situation of similar surd. And what we mean by similar surd is that inside this root, the number we have there is also going to be the number in this root, and it's also going to be the number. And when we consider this thing, we see that none of these surd are similar. Since none of the surd we have here are not similar, addition is not possible. So we now say that this is the result to what we are asked to do there. Now example 2, evaluate root 4 root 3 plus root 6 into 4 root 3 minus root 6. So solution to this. So I will have to reproduce my question. 4 root 3 plus root 6 into 4 root 3 minus root 6. So this becomes, remember the first element here will multiply everything in the second bracket. So that will be written as 4 root 3 against 4 root 3 minus 6. And the second element I have here plus root 6 against 4 root 3 minus root 6. So the result that gives is 4 times 4, 16. 16, we can write it as 16 root 9, or we can as well say 16 times 3, because root 3 times root 3 will automatically give 3, minus 4 root 3 times 6 here we give 24 root 3, plus root 6 times 4 root 3 here as well gives 4 root 18. Then plus times minus here gives minus. Root 6 times root 6 here, I can write that one as 6. Now the result this gives is what? 18 minus 24 root 3 plus 4 root 18 minus 6. Now before I go ahead is to consider this root, this surd here and this surd here. We can see this one is in its basic form, but this one is not yet in its basic form, so it has to be converted back to its basic form. So what I have there is 18, 2 in 18 here 9, 3 in 9 3, and 3 in 3 here gives 1. So the result here is going to be 18 minus 24 root 3 plus 4 multiplied by 3 times 3 times 2 minus 6. And that gives 18 minus 24 root 3 plus 4 times 3 times 3 multiplied by root 2 minus 6. And that gives 18 minus 24 root 3 plus 4 times, remember these two combines to become 3 multiplied by root 2 minus 6. And the result that gives is 18 minus 24 root 3 plus 12 root 2 minus 6. And at this junction we can collect the like term before we finally add or we subtract. So we can see this is a whole number, this is a whole number, this is in surdical form, this is in surdical form. Whole number will combine with no number, while this in one in surdical forms will also combine. So that becomes 18 minus 6 minus 24 root 3 plus 12 root 2. So 18 minus 6 here gives 12. Now minus 24 root 3 plus 12 root 2. We need to consider that this thing is not the operation here, or minus 24 root 3 plus 12 root 2 here, is not feasible, or it's not possible, because these two surds which we have here are not similar. Remember, the addition or subtraction of surd involve similarity of what? Surd. So since the element we have there is not similar, it shows that what the addition or subtraction as given there is not going to be possible. I'm going to take the last question for the day. So that the last one says that we should simplify root 3 plus 1 over root 3 everything was squared. So solution to this one, I have my root 3 plus 1 over root 3 squared. There are many approaches to solving this. One of the approach I can use is this. Now we need to observe this one. We can see this one is in its basic form. But what I have here is not in its basic form. It's division of surd, which needs to be rationalized. So when we rationalize it, rationalization will enable us to put this thing to its basic form. The only way of converting surd to its basic form is by rationalizing. So we have to rationalize first in order to make this thing be in its basic form. When it is not in its basic form, it will now be very easy for us to do what, to square it as given in the question. So that becomes root 3 plus 1 over root 3. And remember, to rationalize is to say multiply by root 3 over root 3. So this gives root 3 plus, 1 times root 3 here gives root 3, everything here over 3. So over 1. Now remember, it's raised to power 2. Everything I have here raised to power 2. And this becomes, now I can add it normally. So LCM of 1 and 3 here give 3. 1 in 3 is 3. 3 times root 3. That gives 3 root 3 plus 3 in 3 here is 1. And 1 times root 3, that gives root 3. Then everything here is to power 2. To continue with this thing is to say that what? Everything I have here should be repeated. Now, addition is possible here because if you compare this side to this side, we can see they are similar. So it means coefficient we add together. That gives 4 root 3 over 3 squared. To continue with this thing means this thing should be repeated 2 times since we have to square it. So that means 4 root 3 over 3 multiplied by 4 root 3 over 3. So when we multiply, that gives 16 multiplied by 3, because root 3 times root 3 will produce what? 3. Everything here over 3. So when this 3 cancel 3 here, the result that gives is 16. And finally, the result of what? Simplifying root 3 plus 1 over root 3 squared gives the value of 16. So this is where we are going to call it a day. And it shows that we still have 1 more or 2 more class before we can complete our study on Surds, because Surds is somehow technical and somehow need much attention. So I will drop the pen here till when next we meet again. Thanks for joining the class.